What's going on, ladies and gentlemen? It's your boy Nurse Bass back with another video. First of all, how am I sounding? And how am I looking, man? Listen, that's neither here nor there. What we are here to talk about today, ladies and gentlemen, I'm excited. It's another installment in our educational series. What we're going to be going over are drop factor style dosage calculation questions. Hey guys, let's get into it.
Are you listening? Nurse Bass. Beast mode. Grinding.
So ladies and gentlemen, what I want to do before we get into any kind of questions, I want to lay a little bit of groundwork, a little bit of foundation, give you some information that is going to help you whenever you're approaching these drop factor style of questions. So you're usually going to be given a given set of information, right? And it is going to consist of a volume, a time, you're going to be given a drop factor, and it's usually going to have you solve in drops per minute. Now, what does this mean? Volume, you're either going to be given in your question a volume in liters, milliliters, or drops. Drops being a physical, literal drop of fluid. We'll get into that in this next slide. You're going to be given a time. So your volume of fluid is going to infuse over a given set of time. This may be over a certain amount of hours or a certain amount of minutes. Then you're going to be given a drop factor. Now, I know that what is a drop factor? We don't know what that is yet, right? Next slide. But it's going to be in drops per mil. So we're talking about drops per mil, and it could be 10, 15, 20 drops per mil, 30 drops per mil, etc. We're going to get to that. But I want you to bear this in the back of your mind. You could be given, like we said, you're usually being asked to solve in drops per minute. How many drops of fluid infused into this patient per minute? Bear in mind, although usually you're supposed to solve in drops per minute, you could be given the drops per minute piece of information in the question and then be asked to solve for any of these other variables instead. So for instance, you could be given all this information and be asked, well, what was the drop factor of the tubing that they were using? Or you could be asked, well, how long did this medication infuse for? They could be asking you to solve for hours or for minutes. So just bear in mind in the back of your mind that these are still considered drop factor style questions. So what are we even talking about when we're talking about drop factor dosage calculation questions? What is a drop factor? We're actually talking about drop factor tubing. Now, as you can see here, we're drawing some tubing with the chamber, and you can see the little drop of normal saline or whatever that is coming down into the chamber. You can think of this concept as a bore, a large bore. So this is large bore tubing. So the size of the drop that's going to be coming down is a large drop because it's large bore tubing. So it's going to only take 10 drops of fluid to equal 1 milliliter of fluid. 10 large drops to equal 1 milliliter of fluid. As we continue on, you can see now we get a little bit more narrow. Now these drops are a little bit smaller because the bore of the tubing is a little bit smaller. And due to that fact, now it's going to take 20 drops of these smaller drops to equal 1 mil. That is a 20 drop per 1 mil tubing. And then as you go down the line, now we're getting even more narrow, even smaller bore tubing. So now these drops of normal saline are even smaller. So now it's going to take 30 drops of fluid to equal that same 1 milliliter of fluid. And as you go through this and you think about this, conceptualize this, and if you can, then it's going to make it easier to grasp whenever you're actually presented with a dosage calculation drop factor style question. Consider this as a similar concept of needles, different gauges on needle sizes. It's the same concept when we're talking about the tubing. It's all about the bore, the size of the inner cannula, if you will, of the tubing, of the needle, whatever it is, a 14 gauge, 18 gauge, so on and so forth. So keep that in the back of your mind as, okay, whenever you're given a question and now you got one of the random given pieces of information is your drop factor of 15 drops per mil. What does that even mean? Don't let it confuse you. Now you'll actually understand what we're talking about. So now that we've gone over some of the fundamentals, let's go ahead and dive into these questions. Hey guys, real quick, I just wanted to let you all know about this amazing company called nursing.com, whose sole purpose is to help prepare aspiring and new nurses for success in this rewarding career. Links down below. They have 4 brand new academies available for whatever stage of the grind you're in. The Pre-Nursing Academy for those aspiring, the Nursing Student Academy for those in the trenches, the absolutely stellar NCLEX Prep Academy with over 99% pass rate, and a program designed to help the new grad nurse navigate this new and intimidating profession. Just pick the path that's right for you. But if funds are tight, don't worry, because nursing.com has a ton of other free resources available to you as well. One day, patient lives will be in your hands. Study like it. Links are in the description. Love you guys. Grind on. All right, guys. So for our first question, what we have here is our MD orders 1 liter bolus of normal saline over 1 hour with a drip factor of 15 drops per mil. So how many drips per minute were infused on this patient? So here's how I want to approach this question, guys. All right, there's a couple of things that we need to know first and foremost. Let's get rid of fluff information anytime that we're looking at these questions. So an MD orders 1 liter bolus of who cares what? A can of Coke, some Starbucks coffee, it don't matter. We're infusing it over 1 hour with a drip factor of 15 drops per mil. All right, so remember, I said we're going to be given information, right? It's usually going to be in the form of volume, time, and a drop factor. And sure enough, that's exactly what we have. We're given our volume of 1 liter. It's going to be given over 1 hour. That's our time. And here we have a drop factor of 15 drops per mil. Now, don't forget, 15 drops per mil. Think back to your drip factor, your drop factor tubing. This is 15 drops. Individual drops equals 1 mil. That's the kind of tubing we're using. Keep that in the back of your mind. Then, of course, like I said, usually you're asked to solve for drops per minute, and so that is what we're going to be solving for. So another principle, key principle, whenever you're solving dosage calculation style questions, never forget, what are you solving for? That's actually a mathematical principle that you always want to keep in the back of your mind. Hey, what are we solving for? So let's go ahead over here to the next slide and let's show our work. Let's go ahead and get into it. What is our given information? Okay, we know that we have 1 liter. It's going to be infusing over 1 hour, and our drop factor is 15 drops per 1 mil. Right? That's our drop factor. Like we said, these are the given pieces of information that you are usually going to be given. And not forgetting what we need to solve for. Drops per minute. We know that we need to solve for drops per minute. Our end volume needs to be in drops, and our end time needs to be in minutes. So since we know that, we already see that our time here is 1 hour. It's in hours. Let's just go ahead and convert that over to minutes. So 1 hour equals 60 minutes. Okay, good. We got it. Our drop factor here is 15 drops per 1 mil. And we infused a total of 1 liter. Let's go ahead and convert that over to mils also. Keep that in mind as well, guys, moving forward. Whenever you're solving drop factor style dosage calculation questions, if you're given any sort of volume in liters, unless your end question is asking you to solve for liters, then just go ahead and convert it over to milliliters and save yourself some trouble. So we need to solve for drops per minute. How many drops were infused into this patient per minute? We've already got our minutes piece, right? We know that we are going over 60 minutes. And so what is our other piece of information that we have here? We have 15 drops per 1 mil. And this is where cross multiplication comes into play. So you guys probably learned this way back when. Maybe you're fuzzy on it. I'm just going to go over this first question as if you have no clue what cross multiplication is. And we'll, for the sake of time, moving forward, we'll speed it up. So we have 15 drops per 1 mil. So our other piece of information that we have is we infused a total of 1,000 mils, right? That's right here. So on the left side, if we have mils on the bottom, then on the right side, mils have to be on the bottom as well. So on the right side, we have 1,000 mils. And up top, that's our unknown. That is our X. Now, if on the bottom we have mils on the left and right, then on the top we have drips or drops, we know that what we're solving for here is our drops. That's what X equals. X equals your drops. So at this point, what you do is you're going to cross multiply. So 15 drops times 1,000 mils equals a total of 15,000 equals. And then whenever you multiply 1 times X, that just leaves you with X. So X, which stood for drops, equals 15,000 total drops of fluid were infused into this patient over the 60 minutes. Well, let's go ahead and do the math then. How many drops per minute, per 1 minute, were infused into this patient? So 15,000 drops divided by 60 minutes equals 250 drops per 1 minute. And as you guys can see up there, that is one of our answer choices, B. So we'll go ahead and go back here, and right there it is. 250 drops per minute were infused into this patient. So that's kind of how you approach these drop factor dosage calculation questions. I wanted to give you guys that first one to kind of lay the foundation. Like I said, keep in mind you're going to be given some set information, a volume, a time, and a drop factor. And you're going to usually be asked to solve for drops per minute. You can go ahead and convert anything in liters into milliliters. Don't forget with these drop factors that this is that actual tubing that we were talking about. And then remembering that simple concept of cross multiplication whenever solving these drop factor questions. Guys, let's go ahead and jump into the second question. So for our second question, our MD orders 250 mils of ceftriaxone to infuse over 4 hours with a drip factor of 30 drops per mil. And again, it's asking how many drops per minute are we solving for. So just like before, let's go ahead and dive into our nitty-gritty information, our given information that we already have, what we know that we have. So volume, 250 mils of who cares are infusing over 4 hours. There's our time. Now, guys, whenever I'm making these jokes and saying who cares what's infusing, of course, read the question. Sometimes they'll throw a curveball at you just to see if you're paying attention. But we're just going over the concepts of how to solve these from a mathematical standpoint. 250 mils infusing over 4 hours, and you have a drop factor of 30 drops per mil. So that's that real skinny tubing, right? You can keep that in your mind. 30 drops per 1 mil. So how many drops per minute are we infusing into this patient? How many drops per minute infused into this patient? So let's go ahead and show our work. So again, our given information, 250 mils were infused. What's our time? It was infused over 4 hours. And our drop factor that they gave us here was 30 drops per 1 mil. And we need to solve for how many drops per minute. Never forget what you're solving for. So we need to solve in drops per minute. So let's go ahead and convert our time over to minutes. 4 hours times 60 minutes in 1 hour equals 240 total minutes. So we already know we're infusing over 240 minutes, right? We're solving for minutes on the bottom, so we already know 240 minutes on the bottom. So our two remaining pieces of information here, we have 30 drops per 1 milliliter. Our other piece of information is 250 mils, since mils is on the bottom on the left. 250 mils goes on the bottom on the right. Drips is what's up top, so we know that X stands for our drips, our drops. So at this point we cross multiply. 1 mil times X equals X. And 250 times 30 equals 7,500. 7,500 drops. Total drops, since that's what X stands for. So 7,500 total drops infused over 240 minutes. Once you do that math, that breaks down to 31.25 drops per minute. Now, an important thing for you guys to understand here, we're talking about drops. This is why it's important to conceptualize what we mean when we're talking about drop factor tubing. We're talking about actual drops of fluid. You cannot have 0.25 drops of fluid, right? You can't have 31.25 drops. It's either 31 or 32. And so whenever you look at your answer choices, you can see that 31 and 32 are both an answer. And since we have 31.25, we're going to round down to 31. And 31 is going to be your answer. 31 drops per minute. Let's go ahead and move on to the next question. So question 3. Our MD orders to infuse 1 liter of D5.5 at a rate of 50 milliliters per hour with a drip factor of 30 drops per mil. How many drops per minute? So this right here is a little bit of a different presentation, but we're going to go ahead and work through it all the same. Let's do it just how we have been. So we are to infuse 1 liter at a rate of 50 milliliters per hour with a drip factor of 30 drops per mil. How many drops per minute? So just like before, we're still solving for drops per minute. Just like before, they gave us a given volume of 1 liter, except this time they didn't give us how many hours it infuses over. They gave us a rate at which it infused. So this 1 liter of fluid infused at a rate of 50 milliliters per hour. So I'll show you guys how to solve for that. And we have a drop factor of 30 drops per mil. So let's go ahead and show our work. So what's our given information? Just like before. And before we even continue, let's just go ahead and convert that over to milliliters. Like we said, that's kind of one of the rules of thumb. Let's just go ahead and do it. This infused at a rate. So this time, instead of a time, we have a rate. This infused at a rate of 50 milliliters per hour. And we have a drop factor on this question of 30 drops per 1 mil. Not forgetting, as always, what are we solving for in this question? We're solving for how many drops per minute infused into this patient. So how do we solve for this? So we know that a total of 1,000 mils infused into this patient, and it did so at a rate of 50 mils per hour. Let's go ahead and cross multiply in this situation. 50 mils per 1 hour. Mils are up top this time, so let's draw our mils up top over here. And we are trying to figure out our time. Hours are on the bottom over here, so we know that X must stand for hours. Cross multiplying, 50 times X is 50X equals 1,000 times 1 is 1,000. And whenever you divide both sides by 50, X equals 20 hours. Remember, X stood for hours. X equals 20 hours. So now we know our time. Let's go ahead and write it over here since we know it now. And at this point, we no longer need this rate information. We'll just go ahead and get rid of that. 1,000 mils infused into this patient over 20 hours. with a drop factor of 30 drops per 1 mil. So, never forgetting what we're solving for at the end. We're solving for drops per minute. Since we have our time of 20 hours over here, let's go ahead and convert that into minutes. Just how we've been doing before. We've been converting our time into minutes right from the get-go. So let's go ahead and do that. 20 hours times 60 minutes per 1 hour equals a total of 1,200 minutes. And so since we now have our minutes, we'll go ahead and put that down here. So now our remaining pieces of information, we know that we have a drop factor of 30 drops per 1 mil, and we have a total volume of 1,000 mils. So as we've been doing so far, let's continue. Let's cross multiply. We have 30 drops per 1 mil. Mils are on the bottom here, so 1,000 mils. And X drops. Whenever you cross multiply, 1 mil times X equals X, and 30 times 1,000 equals 30,000. And so in this case, X equals 30,000 drops. So here we have 30,000 drops infused over 1,200 minutes. And whenever you do that math, what you're left with is 25 drops per 1 minute. And if we go back and look at our answer choices, sure enough, right there we have it as a 25 drops per minute. So a little bit of a different presentation to that drop factor style of question. Instead of giving us an actual time at which this 1 liter infused, instead they gave us a rate this time of 50 mils per hour. But as you can see, we just purely used that rate of 50 mils per hour and our total volume of 1,000 mils to figure out our total time at which our fluids infused. And at that point, our rate no longer mattered. Now we had our 3 primary pieces of information that we usually need: our time, our volume, and our drop factor. And then all we needed to do was solve for drops per minute. Let's go ahead and jump into another example. So question 4, our MD orders to administer 500 mils of vancomycin at a rate of 125 mils per hour with a drop factor of 20 drops per mil. How many drops per minute infused? So let's go ahead, just like before, let's go ahead and highlight our key pieces of information that we need to know. We administered a volume of 500 mils. This time again, we're not actually given the time. As we can see, we're given another rate of 125 mils per hour. And again, we're given our drop factor. This time it's 20 drops per mil. Again, asking to solve for how many drops per minute infused into this patient. Let's go ahead and give you guys another example. Let's show some work. All right, guys, so this time, our given information, we are infusing a total volume of 500 mils at a rate of 125 mils per hour with a drop factor of 20 drops per mil. And again, we're being asked to solve for drops per minute. So just like our previous question, let's go ahead and try and figure out our time. We have a rate, but we need to know the length of time in which this fluid, this volume infused. So we have 500 mils, and it went at a rate of 125 mils per hour. So time for some cross multiplication. Cross multiplying, and whenever you divide both sides by 125, X equals 4 hours. Boom, now we have our time. Now at this point, we don't need to worry about this rate anymore. We'll just go ahead and get rid of that. We don't need any additional information to remain that's going to confuse us. So 4 hours. Good rule of thumb, let's go ahead and convert that over to minutes. So 4 hours times 60 minutes, just like before, equals 240 minutes. So now our remaining pieces of information, just like before, we have our drop factor of 20 drops per mil, and our volume that infuses is 500 total mils. 1 times X is X. 500 times 20 is 10,000. And 10,000 divided by 240 equals 41.66 drops per minute. And let's remember from our previous kind of question, these are actual drops. So it cannot have 41.66 drops. You have to either round down or up. And since it's 41.6, we're going to round up to 42. And here we can see 42 is an option. It's D. So 42 drops per minute is the answer to our question. I hope this is starting to make sense, guys. We're about to dive into question number 5, our 5th and final question. This is going to be a doozy. I want you guys to try and remember at the beginning that you could be given the drops per minute piece of information in the question itself and be asked to solve for something entirely different, one of the other variables. So let's go ahead and dive into question 5, and let's try and bring all of these concepts that I've taught you so far, let's bring them home. So our 5th and final question. You infuse D5W at a rate of 20 drops per minute over 2 hours with a drip factor of 10 drops per mil. What is the total volume infused in milliliters? So this is definitely a different approach, a different type of question than we've been used to seeing. This is still a drop factor question, but it's just a different presentation. I don't want this to alarm you. We're going to go through it and we're going to make sense of it. Let's go ahead and highlight some key pieces of information as we've been doing. There's a method to the madness. Continue to repeat your practices. You infuse whatever at a rate of 20 drops per minute. So boom, now we're being given that drops per minute right out the gate. It's infusing over 2 hours. And we have a drip factor of 10 drops per mil. What is the total volume infused in milliliters? Always remember, what are we solving for? We're solving in milliliters. So let's show our work. Okay, guys, so our given information that we have for this question, we are given a rate of 20 drops per minute. We are given a time of 2 hours, and we're given a drop factor of 10 drops per mil, and we're being asked to solve for our total volume in mils. So when you look at that original question, man, it's very intimidating. There's all kinds of different numerical values, a weird rate of drops per minute now being thrown into the equation, being asked to solve for a volume. It can be intimidating. If you just dissect the question, get out those nitty-gritty need-to-know pieces of information, you can start to break it down. So with this given information that we have, and always bearing in mind what we need to solve for at the end, let's get into it. So let's go ahead and convert our time, as we always have been doing, over into minutes. 2 hours times 60 minutes equals a total of 120 minutes. Let's just get that out of the way. Now, right here from the get-go, we can see we have two things that line up, two things that share numerical values. We have 20 drops per minute, and we have 120 minutes in total. So it looks like we're set up for some cross multiplication. 20 times 120 equals 2,400 drops. So now we have 2,400 drops. Well, what about this third piece of information over here? We know our drop factor is 10 drops per mil. It looks like we may very well be set up for another round of cross multiplication. And we now know that we have a total of 2,400 drops. Well, since drops are on top on the left, let's go ahead and put our drops on top on the right. And we are solving for X mils. And it looks like now we are set up perfectly to solve for our volume, what our total volume infused was. Let's just go ahead and finish out our simple cross multiplication. 10 times X equals 10X. 2,400 times 1 equals 2,400. X equals 240 total milliliters of volume were infused on this patient. And if we go back and look at our answer choices, do we see 240? Sure enough, we do. Our answer choice is C. 240 total mils of volume were infused into this patient. So guys, as you can see, just take this simple information that I've given you about the given information that you're normally going to be given in a question, and how all you need are a couple of those variables to be able to solve for the one missing. So even if they give you a wonky question like this and go ahead and give you the drops per minute right from the get-go in the question and ask you to solve for something entirely different, you can still do so if you keep those simple concepts in the back of your mind. And also, never forgetting what the heck we're even talking about when we talk about drop factors to begin with. Ladies and gentlemen, I appreciate you guys for watching. I hope that this video helped, man. Share this with a cohort. Share this with a fellow nursing student, somebody that you think may be able to take benefit away from it. Leave a comment down below if you have any other alternative ways of solving these drop factor style dosage calculations, or if you have any questions in general. Somebody down there may be able to help. Guys, if you're new to the channel, be sure to hit that subscribe button. We're putting out content every week to motivate, uplift, and inspire you to be the best damn nurse you can be. It's your boy, Nurse Bass, and I'll see you guys next week. Peace.
I'm staying up. I'm wilding out. I'm leaning in. I'm leaning in. Pushing off my sneakers to the ground. I do not jump, I move the earth down. Bear witness to the genius of my sound. Born at the bottom, but now I'm tucked down. Look, I'ma call it swagger. I slip through time zones like a cloak and dagger. Mad rubies on my chain. You can see your name bubbling blood.